Hello everyone. So in this lecture, we'll be seeing the consensus algorithms and how the conflicts are being resolved into the public blockchain and what are the methods, how it works, everything. So let's go to the next slide. So an example of conflict. So let's take an example of conflict, seeing that all the nodes have synchronized the blockchain and are at block number 100. So everybody has the block 100 with them up to block 100 from block 1 till block 100 they have the copy. Everybody has the same copy. So there are three miners in the node in the entire blockchain in the network. So just an example for an example, let's consider that three miners have mined the new block, which is the block number 101 at nearly the same time, right? So of course, since they have mined the block nearly the same time, let's say plus minus 500 millisecond or 100 milliseconds. So of course, now who will be the boss and who will say, okay, my block should be accepted, not yours, right? How this conflicts will get resolved. And because since there is a reward, right, there is a reward, so we need to make sure that we are not creating a problem by actually not offering the reward to the right person. So it has to be logically handled. So how will it happen so that it actually benefit to everyone in the network, not just to the miners, because the reward should be if the everybody is getting the benefit of that block. So here, let's say the new block is 101A, 101B, and 101C. So it means there are three blocks, A, B, and C for the same number 101, 101 block, right? So which one should be the final new block? Again, it's a question because that's a conflict, right? So that's called a conflict, and how will we resolve it? So in Bitcoin, this is a very expensive problem. You know that 25 Bitcoins for one block, and it's worth $18,735 as of today. So it means that it's a very expensive amount we need to solve. So we need to solve this problem very carefully. So answer is the longest chain rule. So in the longest chain rule, what happens is everybody follow the longest chain and ignore the shortest chain. And that's where the one security measure comes, because when if a malicious miner or a malicious hacker actually alter the block number 26, because there are 101 till 100, and somebody has altered a block number 26, then of course that will not matter to the entire blockchain or entire network, because they are following the longest chain, right? So he has to actually fake everything. So that will be very difficult. So let's, in this example, let's say the public blockchains like bitcoins, right? The blockchain conflicts are being resolved by the longest chain rule. Let's say the miner received the first block 101A, then he will start building the next block on top of that 101A first, because that's what the first block he has received. Now in a few seconds, that same miner sees the another block 101B, which was the second block, right? So that miner will keep an eye on that second block as well, but he'll keep building on the first block which he has received, right? So if the next block, let's say 102B, has been identified by someone in the network and has been announced, then that miner will reject and throw out that block and will pick up the 101B and will try to add a new block on top of that 101B, not on 101A, because the longest chain has to be followed, and that someone has already built the block on the another branch means your branch is invalid, you should follow that branch. So that's the idea. So as you can see in there in this diagram, right, if the next block 102B is being detected by another nodes in the blockchain, then that miner will disregard the 101A and will accept the new longest chain, which is 100 block, 101B, and then 102B, and so on, and will keep building on that, and it will reject the 101A. So that's how the conflicts are resolved in this example, right? But how about the private blockchain? That's the big question, right? So make a miner an arbitrator or trusted, simple, right? Or let's say a senior miner is there. Whenever he receives the first block, he will keep that block as a final block and will keep building on other block, and others has to build on that new block, not on the other blocks. So that's how the private blockchain can handle. So they can decide their own consensus algorithms. It can be anything. It can be an arbitrator, or it can be a senior miner, it can be more powerful miner. So it can be decided by the priorities, right? And block received that block received that miner node first will be the final block. Of course, the block received by, sorry, that by is missing. So block received by that miner node, right, first will be the final block. So that can be that minor should be not minor, should be minor. Anyway, so whoever will receive the the that the arbitrator will receive the first block will be accepted. That I already mentioned. So that's it for the consensus based algorithm. It's just a set of rules to decide what should be done in case there is a problem. Of course, they are all algorithmic. Remember, everything is a program. There is no human. It's all softwares which are doing this. Thank you for your time.